If you're planning a brownfield modification, a capital project on an existing unit, or you've got a turnaround coming up, there's one question almost nobody stops to ask before they call in a crew. What are you actually going to do with that information? Because depending on your answer, survey and laser scan are not the same service, and picking the wrong one doesn't just add cost. It shows up during installation, during your shutdown window, when you can least afford to find out the field conditions didn't match what was on paper. Today, I'm going to break down the real difference between traditional surveying and 3D laser scanning, in plain terms, so you can make the right call before the project kicks off. Here's the misconception I run into constantly. People treat survey and laser scan as two names for the same thing, with different price tags. They're not. A traditional survey measures what you tell it to measure. You scope it out, column center lines, tie point locations, key elevations, and the crew captures exactly that. Precise, efficient, and built for that specific question. A 3D laser scan captures the facility as it actually exists. Every pipe, every beam, every piece of equipment, every structural element. In 3 dimensions, with sub-inch accuracy. The result is a point cloud. Millions of data points, each with an exact X, Y, and Z position. That's not a subtle difference. That's a fundamentally different deliverable. And the Z, the vertical axis, what's running above the floor, is exactly where most brownfield project problems come from. A survey tells you where your tie points are in plan. It doesn't tell you what's running at 15 feet above them. Here's the uncomfortable reality in most operating plants. The as-builts don't match what's in the field. Not because anyone did a bad job, because plants evolve. A pipe gets rerouted during a previous tar. A skid gets added. A structural modification gets made in the field. The MOC gets closed out, and the drawing update gets deferred. And then forgotten. Over 5, 10, 20 years of operations, that gap between the drawing set and field reality quietly grows. And nobody knows exactly where the discrepancies are until they matter. We've walked into facilities where the delta ranged from a few inches to several feet. The plants weren't unusual. That's just what happens over time. Let me give you a real example. A processing plant purchased a custom-built piece of equipment designed to fit a specific opening based on the drawings on file. When it arrived on site, a structural beam blocked the installation path by 6 inches. That beam had always been there. It just wasn't in the drawings. The fix was a heavy lift crane through the roof. The cause was design decisions made on documentation that hadn't been field verified. That's not a unique story. It plays out on brownfield projects everywhere, and it's almost always preventable. Now, in the interest of being straight with you, because our job isn't to sell you something you don't need, there are situations where traditional surveying is the right tool. If you need geodetic control, property boundaries, or land survey work, that's the domain of a licensed surveyor. Full stop. And if your scope is genuinely narrow, column center lines on a clean, open site with no overhead complexity, a conventional survey may cover it at a lower cost. In those cases, bringing in a laser scan would mean more data, more cost, and more processing time than the project actually calls for. Knowing when the simpler tool is the right one is part of what makes a vendor worth trusting. But the moment your project involves modifying an existing unit, rerouting pipe, adding equipment, planning a tie-in during a tar, executing a feed or FEL on a brownfield facility, traditional survey falls short for one fundamental reason. It doesn't capture what's running above the floor. The traditional survey falls short for one fundamental reason. It doesn't capture what's running above the floor. In oil and gas, in petrochemical, in any operating plant, the interferences that blow up schedules are almost never at grade. They're at elevation. A survey that gives you X and Y doesn't tell you whether your new spool is going to conflict with an existing 8-inch line running at 18 feet. That answer lives in the Z, and the Z isn't in a traditional survey. With a point cloud, that conflict gets caught in the model, not in the field. If the new piping clashes during the 3D design review, you find it on your screen before the shutdown window opens. The goal is to close out every clash virtually, so your tar scope goes in clean. For pre-tar work, the timing matters too. Scanning 8 to 12 weeks before gives your piping team enough lead time to prefabricate spools against actual field conditions. That's how you compress the shutdown window. And there's one more thing the point cloud gives you that a survey doesn't. It doesn't expire. A traditional survey answers the questions you scoped on the day you scoped them. 3 months later, when a new question comes up, a dimension the FEL team needs, an elevation the piping designer didn't originally ask for, someone has to go back to the field. With a registered point cloud, your engineering team pulls that answer from their desk. No return site visit, no schedule hit, no additional mobilization. The information is already there, captured once, queryable forever. So how do you decide? One question cuts through it. What's running above what I'm trying to tie into or modify? If the answer is I'm not sure, or there's existing piping, cable trays, and structure I haven't fully inventoried, a point cloud is the right foundation for that work. If your scope is strictly 2D, boundary work, control network, a short list of grade level positions with no downstream tie-in, or modification work, conventional survey probably covers it. If you're in early planning for a brownfield project and you're not sure which approach fits, send us the basics: facility type, square footage, what the work is. We'll tell you in writing whether scanning makes sense, and if it doesn't, we'll tell you that too. Link is below. See you in the next one.